Hey developers, welcome back to this new video. And in this video, we'll see a binary search problem that you are seeing the screen. So it's named search insert position. We have to search the index of a particular number that is given. Here's the target. You can see here. We have to find the target's index position if it were inserted or it's already inserted. In this example, it's already there. The 5 is there. So we just return the 5's index value, which is 2. And we take another example like 2 where 2 is not in the list. So if 2 is inserted here, as it is a sorted array, it must be inside like between 1 and 3 here. So the index position will be 1 if it's inserted. And let's take this example. It is given as 7, and if 7 is inserted, it will be in the last position, like it's not in the list at all. So we may return the index of 4, as it is the index of 3, and the next number would be 7 if it's inserted, so we must return 4. Likewise it goes on. So here you can see the problem, like as I said, through the example, like given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in the order. So as it is a sorted array, we can use the binary search algorithm to solve this problem. So let's get started with the binary search algorithm. So before that, if you're new to this channel, remember to subscribe and click that bell icon right next to the subscribe button, so that you'll never miss any of my updates. And if you are not aware of my binary search algorithm video, you can click at the top right corner, like it's a link to the binary search algorithm video. You can see that and come in here. So let's get started with the binary search algorithm. So we need left pointer and a right pointer initially. So it is pointing to len of nums, like a right pointer would be pointing from len of nums, and left would be pointing to 0, which is index. So basically, so we use like for right, we use a len of nums minus 1, which is the last index, but here we are using just len of nums. It's because you can see in this example right here, so it's 7, it's out of index, right? So for avoiding this problem, we are just giving the right as len of nums, not len of nums minus 1, not like this. So we may having a problem if the input were like this. Okay, so we are using like this, and we want mid, but we are not using here, but inside the while loop. Let me create a while loop. So first condition is less than or equal to right. Left is less than or equal to right, which is if left starts here and the right starts here. So if it's interferes, it may interferes because we are giving a equal to, but it cannot go greater than, like right cannot be less than left, or left cannot be greater than right. So it's a condition, first condition that we are using here. And next condition, we are checking the left. It should be less than the len of nums. Okay, so left cannot go further, like after here. So it's out of index. And we are checking the another condition, which is right must be greater than or equal to 0. It cannot go minus 1 like that. So let me minimize it, so that it will be in a single line. And we are here, and those are the conditions that were given. And after that, we are giving a mid value, like every binary search algorithm have a midpoint, where we are dividing, uh, we are finding the median, like left plus right integer division by 2. So to avoid the floating point number, we are giving a integer division. or you can just give a divide and cast it to an integer, however you wish. And we are checking the target. First we are checking that the target is inside the list. If it's inside the list, like it's equal to the number we are checking, we can just return that index. Like in the first example, the 5 is in the list, so we just return the 5's index, which is 2 here. So we just return that, like return mid, because mid is the index. Okay, after that we are checking if it's less than or greater than. If it's less than, we check the left part, and if it's greater than, we check a right part. As we are using a binary search algorithm. So if target is less than nums of mid, we change the right pointer to mid minus 1. So we change the whole algorithm, like I mean whole input value. Like if the target is minimum, then it would be in the left part, so we are just decrementing the right to mid minus 1. And we are having the else part, which is target is greater than the nums of mid, then we must increment the left by increment, like mid plus 1, and it's over. So we are finally returning the left. So this is the algorithm that we used today. So remember first, this case is only works for sorted array. So as the description is given as a sorted array, it is usable, and then only we can use a binary search algorithm to search the insert position. So if it's not the case, we may use something like some other algorithms, which may be any kind of search algorithm, based on the complexities. Yeah. So let's check the test case by running the code. So we are having an error, like a indentation block. So let me minimize it and check it. So it's not in the indentation, so it must be in the indentation. So the whole code, we can just select it, and we can give control plus left bracket, like a right bracket. So it moves by tab space. So it's in the indentation. So let me run the code again. Yeah, it's accepted the test case, like a sample test case. So we can submit the code to test all the test cases. Yeah, it passed all the test cases. So we are at the end of the video. Thanks for watching. And if you have any suggestions or queries about this video, you can let me know in comments. And the same exact code you see in the screen will be in my GitHub page, and the link for that will be in the description. So check it out. And if you are not aware of my Leetcode playlist, you can check it in my description or in my channel page. So thanks for watching. Thank you.